Okay, saya dah mula recording. Thank you for attending the online lecture. So today, basically, that I'm just going to do some introduction on what we are going to do for this semester. So before that, let me open up the slides. Okay, can you see the slide?
Yes, sir.
Yes, sir.
Okay.
Yes, sir. I see, sir.
It's basically just to introduce the introduction on for this particular course. It is EEE3463, right? The title is Signals and Systems, and your section is ZK23B, right? So I got it right,
Yeah.
right?
Yes, sir. Yes, sir.
Okay. So I would like basically that this is what in the schedule. Thursday 9 a.m. to 11, right? And Friday 8 to 10.
Yes, sir.
So if
That's
it's
right,
face
sir.
to face, we have to stick to this time lah. But for the online, if we continue online after these 2 weeks, maybe we can change to the that you proposed on Thursday. On Thursday was from 11 to 1, right? Or something like that. Okay. So this is the course objective, is to prepare the students with the basic foundation of signal and system knowledge. So your first encounter with signal and systems, right? And second course objective is to be able to analyze and explore the signal found in discrete and continuous time systems. So basically that in this course, first half of the semester, we are going to deal with the continuous time system. Half of the semester, we're going to deal with the discrete time systems. And for you to have knowledge in circuit analysis with the ability to perform AC and DC analysis. Okay. So we have 3 objectives. The outcome of this course, basically that you should be able to discuss the continuous time signals, the discrete time and systems, and make use of the characteristics, these characteristics in doing the analysis. That's the first course outcome. The second outcome is that show the output of an LTIC systems analytically from the applied inputs. The third one is apply the Fourier series transformations, Laplace transform in time domain systems, and Z transform to analyze continuous time signals, discrete time signals, and systems. And the fourth one is for you to be able to do the analysis to analyze signal and systems representation using the modern tools. Most probably that we are going to use the MATLAB. Everybody has the MATLAB on their computer?
Not already download
Not,
ke?
Yes, sir.
not yet, sir. Not yet, sir.
Yes, sir.
Not
Not
yet, sir.
yet.
Yes, sir.
So you can start download the app. Uh, and the university's license. So to install MATLAB on your laptop, so that we can use MATLAB. That you can use the MATLAB to do your uh, assignments. Assignments that you require to use the MATLAB. So this is the cost assessments. This is what we have right now. Maybe it will be, maybe there will be some changes that based on the uh, discussion later with the penyelaras, coordinator of the. That so far we have quizzes 5%. We have assignment project 15%. We have midterm test 30%. Final exam 50%. Quizzes, most probably it's about 4 quizzes. Assignments is in the form of projects. Will be one project. Most probably that doing the digital filter design, but that one is not firm yet. But I give you some indication. Most probably that is the digital filter design. Midterm test will be in the week 7. Okay, and we'll cover the analog part of the course, the continuous time systems. Then we'll have a final exam, 50%. Final exam will cover the digital part, the discrete time. Okay. So far, this is what we have. If there is any changes, we'll inform you. These are the syllabus. Today,
Sir, suara saya tak jelas, sir.
Suara saya tak jelas?
Sangkut ke?
Sangkut-sangkut lah. Dengar apa ni? Clear? Tak clear?
Sir.
Ha?
Clear tak
Clear, sir.
clear?
Clear, sir. Clear.
Clear dah? So,
Cakap ni clear.
so basically that is the introduction, convolution, continuous time signals, Laplace transform, continuous time signals, Fourier series and Fourier transform. Then we go into analog frequency response and plots. Then we'll go into digital analog filters. And this will be included in your midterm in week 7. Okay. Then we go into discrete time signals and system, discrete convolution, discrete time systems and analysis using the Z transform, discrete time Fourier transform, discrete Fourier transform, digital filter. For the details of each topic, you can go into the L1. Just list the of the subject that we're going to cover. This course will be very heavy because on your own to do your revision. Because in the lecture, I'm not going to cover in detail. I'm just going to go through on the surface so that you'll be able to study on your own. Okay? So this course is heavy compared to other course. Your reference, the main reference is Mahmud Navi, Signal and System, which I have uploaded the soft copy in MS Team, and you can download and you can use that for your further revision. And we have other references. This one that you can find in our library. Charles Phillips System and Transforms, fourth edition, and a few other textbooks. But I think the main reference is good enough. This is my office. I'm at level 7. So you take the elevator. When you're out from the elevator, so you go to the right wing, and my room is the last room near the staircase. If we have face-to-face or my consultancy hours, can be by appointment, and those are the 2 phone numbers that you can contact me. And I forgot to my email. My email is kamil@nm.e. So
Alright.
that is the introduction. So now I'm going to go into I'm going to go into the second part, which is to show you this L1 a bit more detail. Okay, can you see the L1?
No, sir.
No,
Nampak
sir.
tak?
No,
No,
sir.
sir.
No, sir.
Hilang.
Apa yang you nampak?
Kosong,
Yang
sir.
Cik banyak-banyak ni.
Kosong.
Dia naik nama Faiz lah, sir.
Jangan macam tu.
Nama Faiz.
Serius tak main ni. Apa hal lah?
Sekejap. Kejap. Open share tray. I already open. Nampak tak? Can you see?
Nampak, sir.
Nampak, sir.
Nampak.
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 Course syllabus. Okay. So I've gone through the course objective and course outcome tadi. Main references I've gone through. Okay, this is the topic. Okay. The introduction to signal and system. Basically that we'll do some revision on the classification of signals, basic operation, basic function, and system classification. So we go through, for example, what is the impulse, what is step function, what is the ramp function. We go through that. And then after that, we go through the convolution. The convolution option. Then we have learned the processing a continuous signal in Laplace transform. Then we go into introduction to Fourier series analysis and continue with the Fourier transform properties. For example, scaling, those properties. Then we of Fourier transform. Week 7, a lot, not really 7, the topic 7, a lot to deploy of the frequency response and whatnot. And then after that, analog filter, first order and second order filter, particle, Chebyshev, elliptic filter. Most probably that will cover particles and elliptic filters. After that, we go for midterm. So we finished with the analog part of the signal and systems. The second part is on the digital. So in order to go into a digital analysis, we go into the discrete time and system. So we are look at the classification of signal, basic operation, systems classification in the discrete time signal. Same thing, so basically the counterpart of the continuous convolution. Then we go into discrete time system analysis using Z transform. This is basically this counterpart of Laplace is in the time domain in the analog systems, and Z transform is in the discrete time systems. Then we go to discrete time Fourier transform, discrete Fourier transform, and digital filters. So most probably that the title for the project will give you within this this time lah, maybe within these few weeks, and the final will cover from the discrete time signal to the digital filters. At this moment, that is what we intend to do. Maybe there will be some changes. If there is some changes, I will inform you. Okay. So basically, that lecture is only 42 hours, but you have to spend a lot more time on yourself to study. Okay. So originally it was test 1 and test 2, 2 tests, but we are going to give only one assignment. Basically, it's a project based, and final exam 50%. Right? So that's the L1. So now I'm going to go into a bit of introduction, and this is chapter 1. Let me load the slide first. Okay, can you see the slides? Hello?
Yes, sir.
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
So this is our topic, our first lecture, which is the chapter 1, the introduction to the signal and systems. This slide is based on the slide prepared by Dr. Shida. So chapter 1 will cover introduction to signal and systems. So we will go through on the type of signals, basic functions, operations on the signals, and type of the systems. What is a signal? Signal is basically that any physical quantity that varies with time and may contain some information. For example, sound, speech. Those are type of signals. Right? So in the signal of speech, basically that is the air from your lung goes through your vocal cord. that will break between 60 to 7 kilohertz range. And the output will be your speech. And that speech, we have some information, like what I'm doing now. There is an example of another example of a signal is the radio signal. This is from the electromagnetic waves, travels through air, which is at 3K or up to 300 gigahertz. And the output is the radio signal, where you receive on your handphones. Then after that, converted into, can be data, can be voice, can be video. Those are the examples of a signal. Right? Clear, simple. The systems. The system is basically that the processor which process the signal to become an output. So a system will have an input, will have the processor and the output. For example, in speech, the diaphragm, the mouth, and the tongue. And so that is the systems. For a radio transmission, then you have the transmitter and you have the receiver, and you have the medium in the middle. So that is the system. So signal processor which either to modify the signal or to extract information from the received signal. Okay. So the electrical engineers, like all of you, one day will be basically that deals with the electrical signals. It is mainly voltage, current. Other type of signal can be temperature, vibration, pressure, voice. Those signals in the electrical domain, we take the non-electrical signals and convert into electrical signal in terms of voltage and current. For example, voice, which is in string. Basically, that will the vibration, the vocal cord. We record the voice, the speech. Then after that, convert into the electrical signal in terms of voltage or current. Then you do a processing. Okay? From the sound wave, go into the microphone. Microphone is an input sensor, and this sound wave will vibrate the diaphragm in the microphone and convert into the audio, the voltages and current. So this is the representation of a systems. You have any input signals, go through the processing unit, which is a system, and you have the output signal. And of course, the input signal can be a single input, single output. So CISO, single input, single output, or you have multiple input, multiple output, MIMO, MIMO, input, multiple output. And it can be single input, multiple output. It also can be multiple input and single output. So you can CISO, SISO. It can be MIMO, MIMO. It can be SIMO, can be MISO. So those combinations that you have. So you have 4 combinations of a systems. Single input, single output, multiple input, multiple output, single input, multiple output, multiple input, single output. So I'm not sure whether about this CISO memo is in the textbook or not, but that is basically that 4 types of the systems that we have based on the numbers of input and numbers of output. Okay? Or you want me to put this in the slides later to update the slides?
Sure, sir.
Sure.
Yes, sir.
Sure, sir. Put, sir. Put.
Okay. Because that information basically not in the slides, but what I'm telling you is that based on the experience that we deal as a system engineer, you have multiple normally multiple input, not just one input signal, and the output can be many. Okay. So the input signal normally that is we represent t, a function of time, and the output also the response y of t is the also the function of time. So that is the introduction into the signals and systems. So basic introduction. You can find more detailed introduction in your textbook. Okay. Now the second topic is on types of signals. Right? Type of signal that we are going to cover is analog and digital, deterministic and random, periodic and non-periodic, and even and odd. So we have 4 types of characteristic. Right? So analog and digital. Basically, that to identify the difference between analog and digital is based on the whether the signal is continuous or discrete. If the signal is continuous, it is an analog signal. So it will be real numbers. It can be, for example, 0 point something, 0.125 volt, for example. Whereas for digital signal, you only have values at certain time interval. Right? So basically the identification is based on vertical axis or on the amplitude. Amplitude is continuously defined for analog signal. So for example, like this, you have or at all times, different times you have the values. So this is the analog signal. Whereas for digital signals, you only have values at certain time interval. So amplitude is discretely defined. Okay. So this is the type of signal in terms of analog and digital. In this course, we are going to cover both. First part of the course will be on the analog, and second part of the course will be on the digital. So you will learn on different methods of analysis for analog and for the digital. For analog, normally that we use the Laplace transform or Fourier transform, FFT. Whereas in digital, we got DFT, digital discrete Fourier transform or Z transform for Laplace. So different methods for different type of signal, whether analog or digital. Another type, what do you call it, characteristic is that whether the signal is deterministic or random. Deterministic means that you have a pattern. So it's predictable. you can predict the signal, the behavior of the signal. For example, a sine wave. A sine wave or cosine wave, that is actually predictable. Based on the cosine function or sine function signal. So the deterministic signal, the pattern is predictable. Whereas example of a random signal is noise, a white noise, random noise. In image processing, can be like a salt and pepper noise, or if you get the
Sir,
TV,
suara
for
sir.
example, that you have.
Sir, suara sir sangkut-sangkut.
Tak dengar? Dengar tak suara?
Suara sir macam clear tak clear. Macam start.
Tak clear ke?
Dia macam
Signal rosak sir.
Signal apa ni, unified teruk kot.
unify.
Putus-putus kan?
Dia macam bukan putus-putus dia macam
Okay.
Dia jadi macam
Signal
slow.
ni. Signal dia tak predictable.
Tak boleh. Dah pandai pun.
Dia dah pandai.
The next one is whether the signal is periodic or non-periodic. This is actually, the identification is based on the repetitive of the signal. So a periodic signal has a characteristic of, for example, f of t is equal to f of t plus t equal to f of t plus n t. T, the capital T, is the period of the signal. So the signal is based on the period. Okay, T, the period T. For example, the frequency is simply 1 over T. Omega is equal to 2 pi f is equal to 2 pi over this one. So this is repetitive for a certain period. T naught is the period. So every T naught, it will repeat itself. It will repeat itself. So that is a periodic signal. Non-periodic signal, basically, that it's not repetitive. It doesn't have the pattern, the repetitive pattern that you can observe. Another type of signal is the even and odd.
Tak dengar sir.
And odd signal is based on the. You pun putus-putus juga. So the signal is basically that based on the symmetry of the signal. For even signal, f of t is equal to f minus of t, which is the symmetry
Symmetrical.
at the vertical axis. Okay.
Yeah.
Whereas for the odd signal, f of t is equal to minus f of minus t. Okay, so this is the odd signal. The double symmetry operation is first at the horizontal and then at the vertical. Right? So double symmetry operation basically first horizontal basically that is minus t. Then the second one is at the vertical. This is the minus sign in front. So you have the double minus sign. This is the odd signal. Okay. Basic lagi ni. So the second one, tak tahu, dengar tak? I'm breaking off. Hello.
Hello, sir. Hello. Hello.
Hello sir. Hello sir.
Sir cakap-cakap betul senyap.
Okay.
Tu tiba-tiba hilang, tiba-tiba
Okay.
hilang ke?
Hilang. Sekarang okey.
Okey, sir. Macam sekejap lagi dia tak okey.
Okey.
Dia ikut mood, sir.
Dengar sir.
Dia
Okey.
mula kuat lagi, makin lama makin slow.
Kita ngantuk kot.
Auto tune tu.
Ngantuk kot. Okay. Second one is the basic functions. So the basic functions in the signals, we have unit impulse, unit step, unit ramp, sinusoidal, and exponential and sinc. Okay, we have 2, 4, 6 basic functions. Unit impulse. Unit impulse is also known as Dirac's delta function. Ini nama orang ni, Dirac ni. Okay. Unit impulse function is represented by the delta. So when you draw, you draw like an arrow. Okay.
Ah,
Why an arrow?
dah, sir.
Because the amplitude is in. So a delay impulse. Dengar tak? Impulse with the,
Ah, sir.
so the delay
Sangkut-sangkut.
of a sangkut. Alah. Macam mana saya nak buat An advanced unit impulse basically t plus tau. So this is an advanced unit impulse. And this is the delay unit impulse. This delayed by tau. This is advanced by, okay. So this is the unit step that you have 0, then after that at certain time it come into a certain value after that. The function is represented by u of t. So if the impulse is represented by delta, for unit step is represented by u of t. So a unit step is u t minus tau. Here, this is actually represent a delayed unit step. And advanced unit step is u t plus tau. So this is the advanced unit step. So this is step function. So this is the second one, this is step function. The first one was impulse, the second one is step. The third one is a ramp. A ramp, you start from 0, then it start to increase. Right? And it represented by R of t. at tau, it start to be non-zero. Advanced unit RAM, so start at minus tau here. So at minus tau, it start to becomes non-zero. So this is a unit ramp. So we have involved step ramp sinusoid cosine. So in phase domain, because sine of theta. Sine theta is equal cosine theta minus pi over time domain, we use the omega t. So omega is a radian per second. Okay? Another one is the exponential. So the general exponential function is f of t equal to a exponential, the amplitude exponential of b of t. So b will indicate the function increase. So for example, if you look at the red one is e to the power of x.
Betul.
The green one,
Tak faham, sir.
yes. Tak dengar. So this is the complex function. This is when you have the exponential combined with the sine function or cosine function. And this is called a complex exponential. This is the sine c of t is equal to sine t over t. So the sig function looks like something like this. Okay. Yeah.
Hello.
Ada percakapan ke?
Udah, dah marah.
Sir. 1, 2, 3. Assalamualaikum. Hello.
Yes.
Sir.
Yes. Dengar tak?
Tak, sir. Signal tak ada.
Alamak.
Ha? Apa tu?
Ada monyet kot, sir.
Dengar tak? Ha? Dengar ke?
Sir, sambung, sir. Sambung, sir.
Dengar.
Dengar dah.
Dengar, saya dengar.
Tak. Apa kita stop sini dulu. Tak kita ni waste your time juga ni kalau you tak dengar.
Boleh,
Clear?
sir.
Dengar tak?
Boleh, sir.
Kita stop sini dulu
Sir, betul.
kita sambung
Apa yang betul?
Next
Tuan
class.
ni tak ada.
Banyak ini. It is heavy
Sir.
sikit.
Sir,
Ya.
sir.
Sangkut-sangkut.
Line saya masa akan
Betul,
sangkut
betul,
lepas ni,
betul.
sir.
Tak dengar.
Lepas ni
Bodoh
line
sikit.
saya akan sangkut-sangkut macam ni juga ke, sir? Satu, dua, tiga.
Hello, sir. Sir.
Tahu lah, tengok lah.
Ah?
Hello, sampai sana.
Sir, okey, sir.
Yes. Dengar tak? Ya. Dengar.
Okey, dengar sir.
Dengar tak?
Dengar tapi sangkut-sangkut, sir.
Sir, lepas ni sir declare.
Anak siapa tu?
No.
Actually, that since the signal is not, we continue our lecture next week.
Sir.
In the line is okay.
Betul sir, betul.
Okay.
Apa yang betul?
Benda betul. Baik, sir, baik.
So saya dah record, ada stop dah.
Baik,
Okay.
sir.
So continue. Type of operations.
Alright, sir.
Okay. And any question?